Good day, students. In this clip, we're going to be going over how to apply the chain rule twice in finding the derivative of composite functions. Don't forget to visit our website at mathgotserved.com for access to a wide variety of math tutorials ranging from algebra to calculus. Before we get started, let's take a look at the formula or the chain rule for two functions and see how we can extend the idea to a composition of three functions. So remember the chain rule for two functions. If you wanted to find the derivative d dx of f of g of x, what you do is you find the derivative of the outer function evaluated at the inner times the derivative of the inner function. Okay, just like the outside inside rule. Start from the outside and work your way in. Now what if we wanted to find the derivative of a composition of three functions as opposed to two? If we wanted to find the derivative of f of g of h of x, what will the result be? It's going to be the derivative of the outermost function evaluated at the middle function, evaluated at the middle function composed with the innermost function, g of h of x, times the derivative of the middle function, g prime, evaluated at the innermost function, times the derivative of the innermost function. Okay? Just to help you see it in a different way, we can represent this procedure using a tree. Okay? So let's go ahead and decompose this function. What if you have f of g of h of x? This composite function is made up by composing f and g of h, right? So we have f of x and g of h of x. Since g of h of x is a composite function, it can be decomposed into g and h. Okay? So we have g of x and h of x. So if we compose g and h, we get g of h of x. If we compose f and g, we get f of g of x, g of h of x. Okay? Now, to apply the chain rule twice here, what we'll do is differentiate everything. Okay? So the derivative of f, we have f prime of x, and then differentiate g, we have g prime of x, and then if you differentiate h, you have h prime of x. Now, since f was decomposed, we have to put in what we took out. Okay, we took out g of h of x. So we'll take this function right here, and then we're going to plug it back into the derivative. So we're looking at f prime of x, f prime evaluated at g of h of x. Okay, so this is a composition right here. And then we'll take, since g of x was separated, h of x was taken out of g, after we're done differentiating g, we have to take h of x and plug it back into g prime of x. So for the middle piece of the formula here, you're looking at the derivative of the middle function evaluated at the innermost function. Okay? Since h of x is not a composite function, when we differentiate it, we're done. Okay, so when we combine this and that, we have this result up here. Now let's take a look at an example. So the instructions here are for us to find the y dx. Okay, so find dy dx, where y is a composite function, the square root of sine square x plus 5. Okay, now let's see. Let's go ahead and write this function as a composition of three functions. So what does that mean? Since we have three functions here, well, what are the three functions? First of all, we have the radical function, we have the quadratic function, and we have the trigonometric function, sine x. Okay, so let's go ahead and write it down. So if we want to write, we have f of g of h of x equals the square root of sine square x plus 5. Let's list the functions on the side here. So the outermost one is root x, followed by g of x is a quadratic function. It's kind of hard to see, but it's x squared plus 5. Remember, sine square x is the same thing as sine x squared, okay? And then the innermost one, h of x, is equal to sine x. So that is why we have three functions being composed with one another here. All right, let's go ahead and decompose our functions. So we're going to take out f. The function f is f of x is what? Is the square root of x. Okay. Now if we take out f, if we decompose f and g of h of x, the inner function is going to be g of h of x. Now if you take out a square root from this composite function, you'll be left with sine square x. This is a composition of two functions. Let's go ahead and decompose further. Since this is the composition of two functions, we're going to take out the parent function g. All right, so g of x is the quadratic x squared plus 5, and the innermost function h of x is what? What is the innermost function? H of x is sine x. Remember, this is just a template to help you understand the procedure. If you're doing this on a test, for example, you don't have to go through all of this. This is too much. I just want to make sure that you understand what's going on. And as soon as you understand it, then you can just take off. It becomes really, really easy. All right, now that we have the functions decomposed, we're going to go ahead and find their derivatives, and then we're going to decompose portions of our derivatives, okay? So f of x, the derivative, f prime of x, is 1 over 2 root x. The derivative of g prime of x, is simply 2x. And then the derivative of h prime of x, is cosine x. Okay? Now remember what we're going to do here. We're going to take, since we took out g of h of x from f of x, after differentiating f, we're going to take g of h of x and plug it back into the x here. Okay? And then since g is a composite function, we took out h from g. After differentiating, we're going to plug h of x back into g prime of x. Since h of x was not composite, after differentiating, there's no evaluation at any other function. Okay? So this procedure can be applied to 5, 6, 7, infinite composition of functions. All right? Okay, now let's go ahead and write down the formula again so that we can accurately apply this result we have to this problem. So d dx of, the problem was the square root, wait a minute, we were writing the formula, right? So the formula is f of g of h of x. We said it was f prime of g of h of x times g prime of h of x. That is the derivative of the middle function evaluated at the innermost times the derivative of the innermost function there. All right, so let's go ahead and finish this up. So the derivative of the outermost function evaluated at the composition of the middle and innermost function, instead of 1 over 2 root x, we'll have 1 over 2. Now we're going to plug g of h of x back into f prime of x, okay, because we took it out earlier. So it's going to be 1 over the square root of sine square x plus 5. That's the first piece. And then the next piece, g prime of h of x, is the derivative of the middle function evaluated at the innermost function. So instead of 2x, we're going to have 2 composed with h of x, which is 2 times sine x, like that. All right. And then the derivative of the innermost function is simply cosine x. Since it is not a composite function, we are not plugging anything into it. So that's basically your derivative. Let's make it look pretty. We're going to have, just notice that these 2 and that 2 divide out. And our final result will be sine x, cosine x, divided by the square root of sine square x plus 5. Okay, sine square x plus 5. So that is d dx of the square root of sine square x plus 5. Okay, so that's that. Thanks so much for taking the time to watch this presentation. Please feel free to subscribe to our channel for updates to other tutorials such as this. And you can give us a thumbs up if you like this tutorial. We appreciate it. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day.